All right, so we're gonna do our advanced Python project two, sorry, project 2.3, which is all about creating a Twitter sentiment analysis. And for that purpose, we need to install pip install pandas library and also skykit learn library. All right. So these are the two that we need to install. And moreover, we also need a data set. So let's wait. So if you go on Google, you'll have the sentiment analysis Kaggle. Write it down and download this dataset, sentiment 140 dataset, and just click on download and download it. Make sure that this dataset is also in the same file, in the same folder where your this file gonna be, this code file going to be, because otherwise it will give you an error. All right, now let's do import pandas. Let's start our code. Import pandas as PD from sklearn.feature extraction dot text import tfd vectorizer from sklearn dot model selection import train test split from sklearn.knife base import Berno in NB from sklearn.linear model import logistic regression from sklearn.svm import linear SVC from sklearn.metrics import accuracy underscore score classification report. Now we need to load dataset. My dataset is with the name of archive1. So pd.read underscore csv. So archive1 dot zip encoding equals Latin 1 and header equals none. All right. And df equals df 05 df dot columns equals polarity text, and now print df dot head like this. So and now let's save this and Twitter analysis dot py and run it. Let's see. So this is the first part. There are like 10 to 11 steps that we got to do. All right, so we are gonna run this side by side so that just in case if there are errors, we can navigate them. So it's saying import pandas PD. So it should be as PD. That's why it's giving us an error. All right, save and now run it. And let's see. Run this. And here it is. Here are the. Now we want to keep only positive and negative sentiments. So how do we do that? So df equals df ef dot polarity is not equals to df polarity equals df polarity dot map 0 ratio 0 4 ratio 1 and print df polarity dot value counts. And yes, now let's run this. We are gonna run side by side so that there are no errors, or in case if there are, then we should be able to figure them out side by side too. So here it is, the output is clear. So now let's clean the tweets. So define clean text, text, and return text dot lower and df clean text equals df text dot apply clean text. Now print df and text clean text dot head, and now save it, Control S, and run it again. See if it's working fine or not. Okay, it's working fine. It's cleaning the tweets. Now we need to train test split x train x test y train y test equals train test split. All right. So df clean text df polarity test size equals 0.2 random state equals 42. All right, now print train size length x train print test size length x test. And yeah, now let's run this. So save it, and now let's run it. Here it is, train test and test size. Now we need to perform vectorization. So now vectorizer equals df vectorizer max features 5000 n-gram range equals 1 to x train df equals vectorizer. . Fit transform. . . . Fit transform. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . X train, X test underscore TF-IDF equals vectorizer dot transform X test. Now print TF-IDF shape train X train dot shape. Now print TF-IDF shape test X test TF-IDF dot shape, and now train. All right, we'll do this step next. Let us first run this one, save and run it. And let's see if it's working. Let's take a bit of time. So here it is, TF-IDF shape train test, and perform factorization. And now let's perform train Bernoulli knife based model. So BNB equals Bernoulli NB, and BNB dot fit X train TF-IDF Y train BNB prediction equals BNB dot predict X test TF-IDF. Now print Bernoulli knife base accuracy score Y test BNB prediction. And now print N Bernoulli NB classification report and N classification report Y test BNB grid. All right, and now yeah, we are done doing the Bernoulli one. So all right, let's do one more and then we will run it. Let's train sport vector machine. So SVM equals linear SVC max actor 1000 SVM dot fit X train TF-IDF Y train SVM underscore pred equals SVM dot predict X test TF-IDF. Now let's print SVM accuracy and accuracy score y test svm predict, and now print and svm classification report, and classification report y test svm predict, and yeah, let's run this. Or let's do one more logistic regression one, and then we'll run it all together. Train logistic regression model. So log reg, we're gonna take this variable, logistic regression, max ether 100, log reg dot fit x train tfidf y train log reg prediction equals log reg dot predict x test tfidf print logistic regression accuracy underscore y test log reg underscore predict print logistic regression classification report, and classification report y test log reg underscore prediction, and make prediction on sample tweets. Make prediction on sample tweets. Sample tweets equals, let's say I love this, I hate that, it was okay, not great. Now sample vectorization vectorizer dot transform sample tweets print and sample prediction, sample prediction, and yeah, make predictions on sample tweets. Now let's print Bernoulli NB bnb dot predict sample vec print svm dot predict sample vec print logistic regression log reg dot predict sample vec project. Now let's save it and now run it all together and let's see. Hope there are no errors because this is our complete code now. And let's see how it runs. So, and it's running. Let's take a bit of time. It's taking a bit of time. Let's wait. All right, so there is this error BNB predict is not defined on line 52. So let's go on line 52. So, okay, so it should be BNB dot predict and not like underscore. So run it again, save it, and run it again. Let's see where it goes. All right, so we have another arrow here which says series object has not repeat SVM predict. So now let's do SVM predict. So here we have this dot that we need to remove with comma and now save, and it's on line 60. All right, and now let's run it. Now let's run it. It's running. It's gonna take a bit of time.